Our topic is like modular building construction elements. So those construction with pre-built elements, they have like a lot of advantages. For example, fast and better independent assembly, standardization of the construction process, like logistics, planning, assembly, and so on. Minimizing of costs through streamlining of construction processes. Lightweight construction can be easily removed through demolition and recycling. And those construction are also possible to make with sustainable materials and sustainable construction. Of course, there are always like some limitations. For example, like those modular building construction, the size needs to be shippable, like via ship or train or truck, or they have fixed grid and room size. The historical development. Earliest development for modular building comes from late 19th century. First modules were developed in 1896 by Vejnovic company. They were to develop new construction methods for relatively new reinforced concrete. After these experiments in prefabrication, there were no further developments of these construction methods in the first half of the 20th century. Starting again in the 1960s, modular building became popular in university and professional circles, and was in part further developed to find a competitor to panel construction, for example, panel construction in Soviet Union. Then in 1967, like first skyscrapers made of reinforced concrete room modules, especially in the United States. Also, like one-story modules were developed. Also, wood room modules were developed. Then in 1970s, also in Japan, skyscrapers were made of steel room modules. For example, how do you say
Naga King Capsule Tower?
Naga King Capsule Tower, yes. Yeah, I forgot. Then after the in the late 1970s, there were a lot of critics of this construction, like soulless buildings, faceless buildings, and so on. So it was this modular building. These methods were like dropped by the architects yet again. And in the 1990s and 2000s, modules were rediscovered at a larger scale and also realized in wood. And it was like those were multi-story room modules. For example, like flexible office buildings, administration buildings, and so on. After that, modules soon were developed for housing purposes, like hotels and student residences. Modular buildings were becoming more economical through better fabrication processes, and since 2010, the height of wood modules and like other modules is no longer limited. There were buildings at or about the skyscraper building line, and nowadays modular construction is no longer a rarity and finds applications for most construction tasks, from housing to working. The materials they were like made of, it's usually steel frame. For example, we have here boarding house in Wertheim. It's a container house made of steel. Then reinforced concrete, for example, Naga King Capsule Tower in Tokyo in 1970s, made by Kurokawa. That's a steel frame and lightweight concrete. And then we have wood and wood materials, student residence in Hamburg, in 2017. This building we can use also as hybrid because ground floor is made of reinforced concrete and this residences for students made of wood. Then the hybrid applications, we have residential and commercial building Weiler Park in Bern. The apartments were made of wood. The modules were made of wood. And this hallway slash like balconies, they were made of reinforced concrete because of fire protection. So, Dominic?
And with that, we come to basic construction methods of these modules. And we're keeping in mind to use for our design course using wood materials, but this accounts for any materials you use. And basically using modules, you can think of it like stacking Legos up on top of each other. And like the most basic method is to just stack them on top. And this is by far the simplest and quickest way to do it. But there is there's a limitation for the height you can do. And this is because of the nature of how modules are prefabricated. Because if you try to produce them as serially as possible, so to cut costs in prefabrication, the wall sizes will be, the wall widths will be the same, or the pillar widths throughout the structure. And normally in a building, you would have the most load accumulated at the base of the building. So you would have the strongest walls and pillars there, but now you have the same size of pillar throughout the structure. So it's structurally inefficient in a way, but this can be circumvented by optimizing the building. But still, if you look at one module, you always need a ceiling and the floor. And where those two things meet, you have like two plates on top of each other. So in a way, it can, if they're self-bearing, if they're load-bearing modules, there will always be a little bit of structural inefficiency. And to combat this, on the next slide, you could use a shelf to basically put the modules on top of each other. In this case, you can make the modules as lightweight as possible, and because they're only self-bearing, so you can save up on materials and weight, which will also be easier for transportation. But you miss out on one of the major benefits of modular construction, on how quick and easy it is to stack them on top of each other. The pre-built structure will need time to be built, and even the pre-built structure can be made out of wood or wood materials. And also be made modular in that case, but it's still not as simple as the previous method. And the hybrid of both of these, in the next slide, the hybrids would be combining the two. So you have load-bearing modules stacked on top of each other to their limit, and then you have a shelf basically, and then you continue. And this is actually used for skyrise construction with modules, and with this you basically don't have a height limitation, or like you can go as high as possible. Of course, you have to secure the structure for wind and earthquakes and so on, but this gives you the most freedom in design and the most height you can do. And another method to allow for a more freedom in design is by using fitted panels in between modules. And as we've seen before with the logistics group, we have a lot of size limitations on modules, especially when we try to create big rooms. And with fitted panels, you can basically create larger areas. And these panels can also, I mean, in the graph it's orthogonally, but you can use freeform, you can use slanted angles, you can use curved edges, or you can puncture a hole in the middle for better lighting in the floor below. So you have a lot more freedom in design, but there's also still the limitation of structural height applies, because in this case there's load-bearing modules, or this could also be used in a pre-built structure. And the wood materials, I think the group after us will talk more in depth about them, so we'll skip ahead there.
Mm-hmm.
And now we have some possible space creations with modules here. And of course, depending on how wide you can make the modules, you could put an entire apartment in there. You can also use one module as one room. And something that's being used a lot on construction sites already is using pre-building bathrooms in like a self-bearing module and lifting them into the construction site. So you basically have a fully built bathroom with shower and toilet installed, and floor tiling and all that. And on the right, you have some examples of how these structures could, how this all looks in 3D with like apartments made with fitted panels in between. And what also is possible is to use like the accessibility, make accessibility modules, one with like a staircase in it, or in with the one in the middle of the bottom. There's like an elevator module. So there's a lot of possibility to convert all the parts of a building into modules. And on the next slide, we have some floor plan examples. And of course, on the top, you have the standard corridor and modular arrangement with interior and exterior corridor. You also have the staircase module. But if on the bottom, when you use fitted panels in between as a corridor, you can, for example, use angles to break the monotony of the building, and you can leave out modules in between to get better lighting to the corridor, or create bigger spaces in between, combine interior and exterior corridors, and so on. And one possibility is also to shorten and lengthen the modules. This is also always has to be thought about how to use the wet rooms and basically the piping down. But considering the load-bearing areas, because in the nature of modules, the side walls of the rectangle will always be the load-bearing ones, you can cut out basically the front part or make that longer and create terraces and balconies and so on. And as we've seen with previous examples, a lot of times the first floor or the entrance area of modular buildings will be constructed either through concrete or will require different height. For example, there's a lot of student housing or schools and so on that require a larger entrance area, or for example in residence sometimes there's service rooms or like parking and so on. And so you have to create, so a lot of times a base will be created to accommodate these with different size constraints in the rest of the building. And so you can use different bases for that. You can stack it then on average modules. These, of course, all these bases can be constructed from modular parts as well. But you could put it on beams or even put in other, like a shelf, basically on top of the base. And the logistics group talked about this as well. I'm sorry, this is all in German, but basically this is the greatest constraint of modular building, the size of it all. And here, basically this graph tells you about which size is shippable on public roads in Germany, Austria, and Switzerland. And the standard container size is the 255, like it's even smaller, like 255 is the maximum, and 290 in height. And I mean, if you think about the interior dimensions, you have like 2 meters at most and like 260 in height. So it can be an issue if the modules are getting larger to transport them and get them. This is obviously only for trucks here. So you have to think about routes and how to put these things on the road basically and get to the construction site. And with that in mind, thank you for your attention.